This is the Dataverse podcast brought to you by SDFC. Hi everyone, my name is Rebecca and welcome to the Dataverse podcast. Our topic today is the high performance low cost ventilator, which has been designed in response to the COVID-19 pandemic. To talk about this with me is Tim Powell, a research software engineer at the Hartree Centre who has been working on this research. So I'd like to just start off at the beginning and give everyone a little background to the research. So the project started at the beginning of the pandemic by a group of institutes at CERN over worries over ventilator shortages. They developed what's called the high energy ventilator with guidance from medical experts and specialists. And since then, it's become a huge collaboration between CERN, STFC, and several other universities and organisations. The collaboration in STFC alone includes the Technology Department, the Hartree Centre, of course, the ISIS Neutron and Muon Source, and the Business and Innovation Department. I mean, it's such a great example of collaboration and research. The project is now known as the High Performance Low Cost Ventilator, known as HPLV. And my first question to you, Tim, is what is the need for ventilators in general?
Ventilators, for those that don't know, are devices that support or take over the breathing process. They do this just by pumping air into the lungs. They're generally used by people who are in intensive care units, who are struggling to breathe or who cannot breathe under their own power alone. And this was particularly true for COVID-19. So COVID-19 is especially highlighted that there's a worldwide shortage of ventilators. This is especially true in low and middle income countries. When the pandemic hit and hospital admissions went up, manufacturers did scale up production. However, this mainly benefited high income countries, leaving a lack of ventilation equipment for low and middle income countries. So putting COVID-19 to one side, ventilators are also used widely elsewhere. So pneumonia is the most common infectious cause of death in the world, and the need for adequate respiratory equipment for treatment and management of pneumonia is in really high demand.
So what's so special about the HPLV ventilator then?
It's the natural evolution of the HEV, or high energy ventilator. Because HEV was a really good proof of concept. However, it's not a medically certified device. And there is an awful lot of work in order to turn HEV into a medically certified device. And that is part of what HPLV's aim is. What makes it unique is that it's predominantly aimed as a lower cost device, yet still maintaining a high level of functionality, with the target audience being low to middle income countries. So it uses a lot of already off-the-shelf parts, including well-known parts such as Raspberry Pis. So yeah, that's what makes it unique. Additionally, also in part, it is open source. So it's not just for kind of a company to make a lot of profit on. It's also out there for people to develop and grow their own.
So what was your role in the research? What did you do specifically?
So my role, I had a few different roles. So firstly, I was on the testing team, and secondly, I was also on the UI development team. But in the second role on the UI development team, I had a specific role of ensuring that the quality of the code was robust and that the tests were being implemented in the correct way. So I worked on the testing team, and we wrote the test plan, so which is dissecting the requirements and describing how that can be put into software in terms of tests. So then my work on the UI team, so I helped to develop the UI. So UI stands for user interface. And the work I did on that was also developing the UI, but it was done along the lines of doing code reviews and implementing both unit testing, integration testing, and system testing. So there's 3 different types of testing there. Unit testing verifies that functionality of a specific section of code. Unit testing is basically checking whether the building blocks of the software work independently from each other. So does a function do exactly what it's meant to do? Integration testing verifies that all of these individual building blocks that we've already certified work actually interact together, and they interact in the right way. So if function A talks to function B, does it give it the right things, and then does function B do the right thing with that getting the right output? And then kind of the third thing I worked on was system testing. So this is once it's all been put together, is to test whether the complete integrated system meets the requirements which were detailed at the very start. So we got everything from checking the building blocks, putting it all together, to checking whether the final thing meets the requirements at the end.
So what does being a research software engineer entail, like your day-to-day? What does that look like?
So research software engineers, it's a relatively new still job title, and it grew out of UK academic circles where there was a need for research software which in general is not necessarily always well written. So it was a need to kind of apply proper software engineering concepts to research software. So the majority of research software engineers have some kind of research background where they then develop software engineering skills, and then they then take on the role of research software engineer, and that combines the software engineering expertise with the intimate understanding of research. So that's kind of the classic view of what a research software engineer group does. However, the research software engineering group at Hartree is a little different than the one that you'd find at universities. Our role is still to work on the research software, which we do here at Hartree, but is to provide more of an end-to-end solution for the projects which we're involved with here at the Hartree Centre. So we've got expertise in containerization, cloud computing and architecture, UI development, automated workflows, test implementation, data pipelines, and a lot more. So all of those technologies are the surrounding software infrastructure that kind of makes a project a whole solution.
I'm curious, did you always want to be a research software engineer, or did you have a research background at the beginning?
Yes, that's an interesting question. So my father's a software engineer, and I always said, I'm not going to do that. No, I'm going to go be a researcher. So I did. So I've got a master's in astrophysics where I specifically looked at solar physics, and so my master's was on using ground-based robotic solar telescopes. So that's what I did, and then I did a couple of years of postgraduate research looking at remote sensing as well. So that's satellites looking at the Earth and doing some atmospheric modeling there. And it was through kind of like once I was doing that postgraduate research that I actually got really into doing the coding for it rather than the more research aspect of it. So then that kind of segued myself into a research software engineer where I now code most of the days.
So what advice would you give to someone who's looking to go into your profession to do what you do?
As a research software engineer, I'd say one of the key things is to have a background in something else first. So as I said previously, the majority of research software engineers I know, they didn't study kind of software engineering or your traditional computer science. They often come from a physics or a maths or a bioinformatics or a chemistry background, where they then, similar to me, through the work which they did, developed those software engineering skills and then found that they had an aptitude for it and really liked it. Now, however, saying that, there are also research software engineers who've got fantastic software engineering past in their studies, but it's always been the most useful, in my opinion, to have some kind of research background, so then you can apply the research techniques and the blue sky thinking, and the kind of apply the techniques to not always find an off-the-shelf solution to things.
Well, thank you so much. Thank you for taking the time to speak to me today.
Absolutely all right. It's been a pleasure.